Hi, this is Thomas from Apex Game Tools. In this video we're going to look at height navigation. In Apex Path 2.0 this has changed quite a bit since previous versions. So we're going to look at the different components involved in height navigation. There will be no scripting involved in this video. So to start off, we're going to look at the two main components on the game world that has to do with height navigation. We have this new component called navigation settings, and then we have the grid component, which still has a few options or properties that are related to height navigation. Now, starting with this, we have height sampling as the first section. Now, previously you only had one mode, which was height map. I mean, if you were using height maps or height elevated terrain, you would need a height map to determine the height at any given position on the grid. But now you have a few options. Now the default is height map, so that is what it was before. For height maps you have a few options. You can set the detail level. Normal is recommended, as it says here in the tooltip. High means that it is a bit more accurate, but it will also be somewhat slower. Granularity, you know, this is basically what it always has been, the distance between height samples, so how detailed is the height map. And lastly we have a ledge threshold. Now this has to do with the new height navigation, where units they have the ability to scale certain heights, and this basically differentiates between what is a scale or what is a slope. So if a unit, when moving from one cell to another, encounters a slope, which in this case would be a ledge, which in this case would be some slope that is less than 10 degrees, then it would be seen as a scalable height. Otherwise it will be seen as a slope. And we will get to those the differences between those two in just a second. So for height sampling we have a few other options. Well, we have no height sampling at all. Obviously if you don't have any height differences, we just have a flat map, you should use this to reduce the overhead. But we also have raycasting as an option now. Now obviously live raycasting does cost a bit more on performance, but it also reduces the need for a height map, or removes the need for a height map. So if you go with raycasting, there will be no height map, so there will be no memory footprint from a height map, which in some cases can be quite large. So instead you will pay a price on CPU cycles. There will be a little more of that when the units move, because they need to height sample using raycasts. But it is definitely still high performant. Now what suits you the best? Well, that's up to you, obviously. Again, with raycasting you have similar options, granularity and ledge threshold, meaning the same things as before. We also have a spherecast option, which is, well, it may make it into live, it may not. This is in some cases a bit more accurate, especially if you have spherical colliders on your units, but it is also somewhat more heavy. For now we'll stick to the height map, and then we'll move on to the next section down here. So this has to do with navigation settings. Now units have, and they always had, the ability to scale slopes and also to climb onto geometry of a certain height. These two, they were previously called max scale height for that, and it's always been like this slope angle. So you can now define this on a global level. This means that this will be in effect for all units. The max slope in this case, 45 degrees. They can climb onto something that is half a meter high, And then we have this new thing that is called drop height, which obviously is the reverse of a climb, so it can drop down 5 meters. So yeah. Now, as you can see, this is an option that you can tick on and off. If you tick it off, it will mean that it is no longer global, so this is something that you can set on each individual unit. Now, we'll leave this on for now. Moving on to the grid component. Now, most of this has nothing to do with height navigation, but down here, in case that you are actually using height maps, you have some options. The lookup type governs how the lookup of height data is saved. So you can either use this as the default now, quad tree. This is an optimized data structure for height map data. And I will show you just in a second a visualization of this. The other option is a dictionary. This is a bit more memory heavy, but it is also faster. So again, it's a trade-off. Dictionary uses more memory, quite a lot more actually. Again, of course, depending on how many height differences you have on the map. If you have lots of open areas like you have here, the dictionary will use a lot more than the quad tree. The quad tree, on the other hand, is slower on the lookups, so it is, as I said, a trade-off. And tree depth has to use, it's an advanced option. It basically means when the tree will stop and convert the rest of the height data into local dictionaries. Now obviously these settings are only relevant if you actually use height maps, so if we go up here and we switch to raycasting, these will go away. So that was it for the components. So now let's have a look at the scene here. So I've set up a small obstacle course. As you can see, we have 2 units, and we have a patrol route around these that the unit should follow. And right now we have these global height navigation settings that allow us to scale slopes of 45 degrees, climb onto 0.5 meters of height, and drop from 5 meters. So running that, we will see our units moving around this platform because that is actually 1 high, so we cannot scale that. They will move up the stairs, and they will also be able to drop down from the stairs, and they will also be able to move across this one. This is 45 degrees. But they will not, well, they would be able to scale this, but they cannot drop from here because there's a 6 meter drop. Okay, oh yeah, so what I also wanted to show you is the visualization that we've added to the grid. You already know we have the layout. We also have accessibility that will show you the lines of where you can actually go. We've added a few lines. You can see that the green here represent connections that are descent only, so you can only drop. There can also be blue lines or purple lines representing ascent only. And then we also have a third option for the draw mode, and that's the height overlay. And as you can see now that we are in the height map is stored in a quad tree, and this basically represents different areas of same height. So in a square you will also always have the same height. Now these that are filled out, these represent areas where there's a local dictionary, because the heights differences would cause the tree to go below the depth that you have specified. Like here, we've specified a depth of 5, maximum depth of 5. Okay, so that was maybe a bit advanced, but moving on to looking at the individual settings. So if we turn this off, we will actually now be able to set individual settings for each unit. So this appears under the unit component. As you can see here, we now have a height navigation section, which allows me to tell the orange unit that what it can do. So we've set this can now scale a slope of 31 degrees, can scale 1 meter, and can drop from 6. And the green can scale 46 degrees, just to allow for some floating point areas on the slopes here. It can climb 0.5 and drop from 5. So let's see that in action. As you can see now, they pick different routes because they now have different capabilities. So the orange unit cannot scale this slope, and the green unit cannot drop from up here, but the orange unit can, so it will do that. So that's it. Those are the changes made to height navigation. Hope that makes sense. See you in the next video.